Good afternoon. I am Shalini Singla from GPC Kundi Majra. Today my topic is numerical problems on DC circuits, Ohm's law and series and parallel combination of resistances. So first of all we will start with the numerical which is based on current. A current of 1 ampere is flowing through a conductor find the number of electrons flowing through it in 1 second. So we are given that current of 1 ampere is flowing through a conductor and time is 1 second, and we have to find the number of electrons flowing through the conductor. As we know that the current is equal to charge flowing through the conductor per unit time, and the charge is equal to number of electrons into charge on each electron upon T. As we know that the charge on each electron is 1.6 into 10 raised to power minus 19 coulomb, and T is equal to 1 second, and the current is given as 1 ampere. So putting these values, we can find the value of N. N is equal to I into T upon E. Current I is equal to 1 into time is also 1 second, and E is 1.6 into 10 raised to power minus 19 coulomb. So solving it, we get the value which is equal to 6.25 into 10 raised to power minus plus 18 electrons. So if 1 ampere of current is flowing, it means 6.25 into 10 raised to power 18 electrons are flowing through that conductor. Now we come to second problem. A current of 1 microampere is flowing through a wire. Find the number of electrons flowing in it in 1 second. So the solution is, in this case the current I is equal to 1 microampere. We know that 1 micro is equal to 10 raised to power minus 6 ampere. Time T is equal to 1 second, and we have to find the number of electrons. N is equal to I into T upon E. So this is equal to 10 raised to power minus 6 into 1 upon 1.6 into 10 raised to power minus 19. So on solving it, we get a value 6.25 into 10 raised to power 12. So the number of electrons is 6.25 into 10 raised to power 12. So these are two numericals which are based on the current. The next is the numerical, which is based on the resistance resistivity. It says that calculate the resistance of a conductor having a length of 3 kilometer and area of cross section 32 mm square. The resistivity is 18 into 10 raised to power minus 9 ohm meter. The unit of resistivity is ohm meter. So we have to find the resistance. So as we know that a resistance of any conductor depends upon three factors. First is the nature of metal used. It depends upon the type of metal which is used, upon the length of the material and area of cross section of the wire. So it depends upon these three factors. So we are given the resistivity rho is equal to 18 into 10 raised to power minus 9 ohm meter. The length is 3 kilometer. 3 kilometer is equal to 3 into 10 raised to power 3 meter, and area of cross section is 32 millimeter square. This can be also written as 32 into 10 raised to power minus 6 meter square. 1 millimeter square is equal to 10 raised to power minus 6 meter square. So putting these values, we can find the resistance. So the resistivity is 18 into 10 raised to power 9 into length is 3 into 10 raised to power 3 divided by area, which is 32 into 10 raised to power minus 6. So when we solve it, we get the result as 1.6875 ohm. So on solving, we get the value of resistance, which is equal to this one. So the next problem is, in this case we will find the specific resistance. A potential difference of 100 volts exists between ends of a conductor of length 300 centimeter and diameter 0.25 millimeter. The current flowing through it is 2 ampere. Find the value of specific resistance. So, the solution is, in this case the potential difference which is applied to a given resistor, we can show it by a diagram. This is a resistance, this is battery applied which gives a potential V, and a current I is flowing through the resistance. The value of potential V is equal to 100 volts, and the current is I is equal to 2 ampere. So, firstly we will find the value of the resistance R. We know that V is equal to IR. This is from Ohm's law. So, R is equal to the ratio of potential V to the current I. So, this is equal to 100 upon 2. The value of resistance comes out to be equal to 50 ohm. Now, the length of the conductor is 300 centimeter, which is also equal to, which it can be converted into meter. So, it is equal to 3 meter, and the diameter of the wire is 0.25 millimeter. This is equal to 0.25 into 10 raised to power minus 3 meter. So, the area of cross section of the wire is equal to pi d square upon 4. So, this is equal to pi upon 4 into 0.25 into 10 raised to power minus 3 whole square. So, as we know that R is equal to rho L upon A. So, from this we get the value of resistivity rho is equal to R A upon L. So, we can put different values. R is equal to 50, area upon length is 3 meter. So, rho is equal to 50 into pi by 3 into 4 into 0.25 into 10 raised to power minus 3 whole square. So, when we solve it, we get the result as 81.8 into 10 raised to power minus 8 ohm into meter. So, this is the value of the resistance which comes out. Now, we come to the next numerical. A wire of length 1 meter and resistance 5 ohm is stretched to double its length. Find the new resistance of the wire. So, the solution is, suppose we have a given wire. When we stretch it, its area of cross section decreased and its length gets doubled. Suppose it is 1 meter, here it gets 2 meter upon stretching. So L1 can be taken as 1 meter and L2 is 2 meter. So when we stretch something, its volume remains constant. So V1 is equal to V2. If the volume here is V1 and the new volume is V2, so V1 is equal to V2. Now we know that volume is equal to area of cross section into length of the wire. So V1 is equal to A1 L1 and V2 is equal to E2 into L2. So A1 into L1 is equal to E2 into L2. Now we know that resistance is equal to rho L upon A. Since the material of the wire is same, so the value of rho is a constant, so it does not change. If the resistance of the first wire is R1, length is L1, area is A1, and the new resistance is R2, so this is equal to rho L2 upon A2. When we divide R2 by R1, this is equal to L2 upon L1 into A1 upon A2. So the ratio of L2 upon L1 is 2 and A1 upon A2 is also equal to, from this equation we have A2 upon A1 is equal to L1 upon L2. So this is also equal to 2. So this is, the ratio is 4. So the value of R2 is equal to 4 into 1, which comes out to be equal to 4 ohm. Sorry, the value of resistance R1 is 5. So 4 into 5 comes out to be equal to 20 ohm. This is the new resistance of the wire. It gets 4 times. Now we come to the next numerical. A copper wire of diameter 2 centimeter has a resistance of 0.525 ohm. It is drawn to reduce its diameter to 50%. Find its new resistance. So the solution is, it is same as that of the previous one. We have a wire, its resistance is given, which is 0.25 ohm, and its diameter is, this diameter is 2 centimeter. Now it is stretched so that its diameter is reduced to 50%, means it remains half of the previous one. On stretching, it is equal to 1 centimeter. So we have to find the new resistance R2. R1 is equal to 0.25 ohm. So this is, D1 is equal to 2 centimeter, D2 is equal to 1 centimeter. So as we have solved earlier, the volume of the wire remains constants. V1 is equal to V2. So A1 L1 is equal to A2 into L2. So the ratio of lengths L1 upon L2, it comes out to be equal to A2 upon A1. Now area of cross section of the wire is pi d2 square upon 4. This is the new area of cross section, and the old one is pi d1 square upon 4. So it is equal to d2 square upon d1 square. So this is the ratio of lengths d2 square upon d1 square. This comes out to equal to 2 square upon 1 square, which is equal to 4. So the ratio of the lengths L1 upon L2 is equal to 4. Now we will calculate the ratio of areas. A1 upon A2 is equal to pi d1 square upon 4 upon pi d2 square by 4. So this is equal to d1 square upon d2 square, which is equal to 2 square upon 1 square. This is also equal to 4. Here L2 upon L1 is equal to 4. Now we know that resistance is equal to rho L upon A. So R1 is equal to L1 upon A1. The rho remains a constant, and R2 is equal to rho L2 upon A2. So on dividing R2 upon R1, this is equal to L2 upon L1 into A1 upon A2. So if we put the values of L2 upon L1, which is 4, and the value of A1 upon A2 is also 4, so this is equal to 16. So R2 is equal to 16 into 0.25 ohm. So this comes out to be equal to 4. We can take 100 here, and this is 4. So 16 divided by 4 is 4. So the value of R2 is 4 ohm. So this is the result. Now we come to the next numerical, which is based on series and parallel combination. Find the total resistance between P and Q in the following circuit. So we are given a circuit which is this point is P and this is Q. Here we have a combination of resistances in series and in parallel. The value of this one resistance is 1 ohm. This is also 1 ohm. This is 3 ohm, 3 ohm, and 3 ohm. This point is A and this point is B. So we have to find the total equivalent resistance between points P and Q. We can solve it. Firstly, we will see that the these three resistances 3 ohm, 3 ohm, and 3 ohm, these are in parallel. When we take their parallel combination, 1 upon Rp is equal to 1 upon 3 plus 1 upon 3 and plus 1 upon 3. this comes out to be equal to 1. So the total parallel resistance is equal to 1 ohm. Now we can draw the diagram as this 1 ohm resistance, this point is P and this is A. Between A and B we have find the total resistance, which is also equal to 1 ohm. This point is Q. Between B and Q again the resistance is 1 ohm. Now we have three resistances 1, 1 and 1 which are connected in series. So the total resistance in series, it is equal to 1 plus 1 plus 1, which is a simple sum of these three resistances. It comes out to be equal to 3. So RS is equal to 3 ohm. So this is our final result. Now the next is find the equivalent resistance between A and C. So here we have given a circuit. This point is A, C, this is B and this is D. We have to find the resistance between A and C points. The value of resistance is this is 3 ohm, this is 7 ohm, this is 10 ohm, this is 5 ohm and this is also 5 ohm. Now we can draw it again, like we take here the point A and this is 3 ohm resistance, 7 ohm resistance, these are connected in series, and here is 10 ohm resistance, and below we have two resistances, 5 ohm resistance and 5 ohm resistance, which are again in series. So we have redrawn this circuit to simplify it. So in this circuit we can see 3 ohm and 7 ohm resistances are in series. So here we have total resistance as 10 ohm, here also 10 ohm, 5 ohm and 5 ohm. If we take its combination, it comes out equal to 10 ohm. So here we have between A and C points we have three resistances connected in parallel, each of 10 ohm. So when we take their parallel combination, total 1 upon Rp is equal to 1 upon 10 plus 1 upon 10 plus 1 upon 10. So this is equal to 3 upon 10. So Rp is equal to 10 upon 3, which is equal to 3.33 ohm. So this is our result. Now the next numerical, find the effective resistance between A and B. In this case we have a diagram. Here we have three resistances, 4 ohm, 4 ohm and 4 ohm each. Here again we have two resistances, 4 ohm, 4 ohm. So this point is A, this point is B. So we have to find the net resistance between points A and B. If we see this